Hello. So what I'm going to do here is work through the practice exams for exam 3, the problems number 19. So if we have 4 practice exams, I'll just go through in order. Um, the first practice exam, that was A, read to use to complete the square to rewrite x squared plus 2x. First thing to be mindful of is make sure that the leading coefficient is 1, which it is. Next would be to go to the coefficient of x, which is 2, and then take half of it or multiply it by 1/2, and that will give us 1. Take that 1 and square it, gives you 1. 1 is what I've been calling in class the magic number. Yeah. So with that, we can rewrite our little quadratic and bring in the magic number here, but remembering that we can't just bring this in out of thin air without compensating, which we're doing by subtracting 1 back out. So I put in the parentheses here very deliberately to highlight the perfect square trinomial part, and off to the right will be some leftover term, basically. That's to be expected. Well, I think we're almost done because since the expression inside the parentheses is a perfect square trinomial, it must be the case that it equals a squared binomial. And to check that, to make sure everything is right, you take your first term, square it. Does it give you back the first of the 3 terms? Yes, it does. The second term in the binomial, if you square it, do you get the third term in the trinomial? Yes, we certainly do. And then the last step is to say, okay, x times 1, that's 1x, double that gives us 2x. Is that the middle term in the trinomial? And it is, so it's all good. It's all good. So that should do the trick. That would be the answer there. We've rewritten the given quadratic into a form that can be very useful, and we've done that by completing the square. So now let's come down to the next example. This, I believe, is from B. So same procedure. Make sure the leading coefficient is 1. It is. No complications there. Pick on the coefficient of the x term and multiply it by 1/2. And I believe we get -4 out of that. Take that number, -4, and square it, and then we get 16. 16 is the magic number. And now we bring in and out, if you like, the magic number, but I'm trying to do this in a systematic way. We're bringing in 16, but we're also, I'm sorry, not equals, subtract 16. Put the equal sign over there. Okay, so we have x squared minus 8x plus 16, and then a minus 16 off to the right there. And if we've done this right, what we have in the blue parentheses is a perfect square trinomial. There we go. And let's see, an x minus 4 quantity squared minus 16. All right, well, where did this come from? Well, let's see. Square the first, x squared. Do we have x squared as the first term of the trinomial? We do. -4 squared is positive 16, and that is the third term. Very good. Now the last check, do the multiply. Multiply 4 times x, -4x. Yes. Double it, -8x, which is the middle term of the trinomial. So everything is looking good. And I believe that is it. And we can put a box around it, and we're done. All right. I think that takes care of practice exam B. Let me bring in, I think, was the problem from C. I think it looks like this. Oh, that would help to actually see it. There you go. All right. Right on. Okay. Okay, so first check is that the leading coefficient is 1. It is. And now we're off to the races. Take -10 multiplied by 1/2, which equals -5. Yeah. and then square your -5. That gives us 25. 25 is the so-called magic number. I say so-called because I made up that phrase just to be cute and just to give it something distinctive. All right. Well, now the magic number comes in and out, but it comes in and out in a very useful way, like that. Yeah. So it comes in to play the role of completing a square, but since we did bring in the 25 kind of out of nowhere, we need to keep the quality preserved. We need to subtract it back out. Well, let's see. As before, we should be ending up with a perfect square trinomial in the parentheses. And we'll find out if we really have done that by saying, okay, is it really true that x plus 5 quantity squared gives you back that trinomial up above? So let's see here. We have x squared, yeah. -5 squared is 25 positive. Yes, okay, good. 5 times x is 5x, -5x, double it, -10x. So everything is good. We're good. So far, been pretty tidy, I hope. The last example, I wanted to give a little more room to just because, well, we'll find out if I'm justified being a little more careful on this one. All right. So here's x squared plus 5x. All right, so step 1, make sure leading coefficient is 1. It is. Step 2, take half of 5, which is 5 halves. So now we have a fraction here. But the procedure is the same. It's just I'm just noting we have a fraction here, and it's not going to disappear. So no problem. You just take 5 halves and square it. You'll have 25 fourths. 25 fourths is the magic number. So here we go. You'll just come down. Same procedure, no difference. We have x squared plus 5x, and then in blue, I'm going to bring in the magic number part here, which will be plus 25 fourths, parentheses, minus 25 fourths. So no difference in the procedure. It's just you have a fraction. And that, I know, it gets a little scary, adds a little complication a little bit, but the procedure is no different. And the idea now is we still have a perfect square trinomial here. It's just they're not all integers, the numbers. No problem. Let's see if we're good. I think that's what's that. Okay, now let's find out if the binomial, the squared binomial, really lives up to its role here. X squared is the first term of the trinomial. This is good. Okay, it takes a little more work here. You have to think 5 over 2 squared. So you'd square the top. 5 squared is 25. The 2 squared is 4, so that checks very well. Lastly, multiply 5 halves times x. That would give you 5 halves x. Now you double that. 5 halves times 2 gives you 5x. And I'll write that off to the right here maybe. So we're saying 5 halves x times 2 gives you, well, you could write it this way. You could say 10x over 2 and just cancel. You'd be left with 5x. And 5x was the middle term of the trinomial. So everything is checked out wonderfully. And so I hope these 4 examples will help the number 19 slot on the practice exams.